and welcome to the last session on Wednesday. You all have incredible stamina. It's our 10th, so give yourself a little hand. You've made it. Today we're going to be talking to you about taking an Azure OpenAI chat application from POC to production. I'm Rob Bagby. I'm with the Patterns and Practices team. We manage CAF, WAF, and AAC, the Cloud Adoption Framework, the Well-Architected Framework, and Azure Architecture Center. This is my colleague, Ritesh. Ritesh is with ISE, Industry Solutions Engineering. They work with customers out in the field, our top customers, and help them deliver solutions on Azure. Ritesh has worked with dozens of customers, basically on some of the same solutions we're going to be talking about today. So as I mentioned, we're going to be talking about taking a POC to production. So we're going to be covering infrastructure. We're going to be covering the role of a gateway, as well as building the solution itself. So as we said, we're starting with the POC, didn't we?
Absolutely.
You got a POC for us, Ritesh?
Absolutely. Let's get started.
Bring it on. Yep, sorry.
So I have a simple POC built on PromptFlow. This POC is called Chat with Wikipedia. It's a simple RAG application in which it accepts a user input, and it goes through a series of steps and generates an output. Now, when you look at the series of steps, the things that it does, it takes a question, and then it basically, first thing it does is extracts the intent out of the question, and then using a large language model, and then using that intent, it queries Wikipedia. And when it queries Wikipedia, it gets back the search results, which are in terms of HTTP. They're basically hyperlinks to the various different pages within Wikipedia. Now, the next thing it does as part of this is it goes to each of the URLs that it found, extracts the content out of it, does some processing on them, it generates a context, and then eventually, with the original question, it sends that context to a large language model like an Azure OpenAI, and then gets the final answer, which it sends it back to the user. Now, we can simply run this over here. Since this is a POC application, we can simply say chat, and we can say, what is ChatGPT? So it will process all the steps I just mentioned, and it will retrieve the response from it and give it back to me. Now, this is a simple POC application built as a developer by me. And this is also available as part of your PromptFlow samples. How about doing some changes to it because we want to take this to production, how about doing a few changes to it? One, we don't want to use Wikipedia as a source of information. We want to use a policy called DORA, for example. And DORA stands for Digital Operational Resilience Act, primarily meant for financial entities. And we want to use that and provide our users with the facilities so that they can query this act or a policy and get answers from it. What does a DORA document look like? It simply looks like this. It's a PDF file, but you could have more PDF files, a number of PDF files, which you want to use and get answers from to your users. Second, what we also want to do, instead of going to Wikipedia, as I mentioned, we also want to introduce Search AI into it so that we get these PDF files, we index them by chunking eventually, and put them so that we can query and get the response out of it and then use with large language models. This is what we want to do. So the document is not that important. The data is not important over here in this case. The core concept that we want to show is how do we productionize this? What are the things we need to do to make sure that it is production ready? So being said that,
let's start with step one.
Let's start with step one.
Step one, we're going to hit the infrastructure. So I think it's kind of important to look at the architecture of the POC. You can see this little blue guy, that's Ritesh, sends a request over to the intelligent application. In our example there, that was the chat UI that we were using. The intelligent application sends that request over to the orchestrator. That's the PromptFlow code running inside of the machine learning workspace. Now, in Ritesh's demo, it went down to Wikipedia, but in our real world, we really wanted to go to Azure AI Search or another vector database. Once we get that grounding information, we're going to send that over to the Azure OpenAI service, where it's going to reason over that information and send you your results. So this is the prototype. This is the POC. But we want to get to something that's well architected. We want something that's going to adhere to our well architected principles. So let's take a look at something like this, where there's 11 billion boxes. I counted them all. So let's take a look at how a request flow works in, say, an architecture like this. Once again, the user's going to send a request, but this time the request is going to go to the Azure Application Gateway with Web Application Firewall. The firewall is going to inspect that request to make sure nothing funny is going on. The call is going to go then through a private endpoint in your private network, which is then going to route to Azure App Service. That's where our UI is running, inside of Azure App Service. And it's spread across availability zones, so it has zonal redundancy. When Azure App Service, which is a PaaS service, wants to make a call back into the network, it calls through a virtual interface. It now can then make a call through a private endpoint in our virtual network and then talk to whatever downstream services it wants. In this case, it wants to talk to the managed online endpoint there on the right. That managed online endpoint is where our prompt flow code was deployed. It's actually, the managed online endpoint actually acts as a load balancer and a router to the code that's running inside of that compute cluster. Now that code running, our prompt flow code is running inside of a managed virtual network that gets deployed as part of the machine learning workspace. And we'll show you later how that gets configured. And so in order for it to talk to its downstream services, it talks through some managed private endpoints to talk to, get its grounding data, and then to get the AI search data. It's fairly complex, fairly involved.
So Rob, I believe this is the first step that you're talking about, and this all involves about the infrastructure.
This is all about the infrastructure. We've got more infrastructure to talk about. We've got a second architecture that we can use. You'll remember before, the prompt flow code was deployed out inside of the machine learning workspace. But here it's deployed out in app services. And we're going to cover why you might follow this architecture in just a minute. But now that code, the prompt flow code or your orchestration code, is sitting right next to your UI code. And so if it wants to talk to, say, Azure AI Search or Azure OpenAI, it calls back into the virtual network through the virtual interface and uses a private endpoint to talk to both those services. Now, how would you deploy that code from Machine Learning Workspace? Well, it would deploy that code over to a container registry, which then the app service can reach, again, through the virtual interface. So we've seen this very big, complex model in our very simple POC. How do we get from this POC to that big, giant architecture? That's really why we're here. The answer is we've got published guidance for all of that. If you look out here, and you'll have access to the slide decks, you can download them. The bottom two links show well-architected framework service guides. Those service guides, let's take a look at some of those. Those service guides are like your cheat sheet for services like Azure OpenAI. If you look at the pillars, so you can think of, kind of backing up, we said we had a couple different sets of guidance. How do we get rid of this? There we go. A couple different sets of guidance. We've got two service guides. We've got one for the Azure OpenAI and one for Azure Machine Learning. And you can think of these service guides as kind of your cheat sheets towards all of the thoughts you need to be thinking about, the design considerations and recommendations you need to be considering when working with these services in your architectures. So they cover across all of the 5 principles: reliability, performance efficiency, cost optimization, et cetera. So you can think of these as your cheat sheets. Now moving over to our architectures, this is the baseline OpenAI end-to-end chat reference architecture. And let's just take a quick look at a high level of the type of guidance that you're going to be able to find in here. You can see that this is the same architecture that I showed you within the slides. And that's what this reference architecture is based around. The first thing you'll see is a listing of the components that are available in that architecture. Then we start walking through some of the high-level design considerations you need to take into account. Obviously, networking is a high-level design consideration you really need to be looking at, so we kind of go into depth here. You can see we cover those same network flows I showed you within the slide with all of the animations. We break the flows down in inbound network flow, the app service to PaaS services, and then lastly, the call over to our machine learning services. And you can see that we've got details in here. You can follow along within the documents. We then cover ingress to machine learning. Because our machine learning workspace that we've been working in as data scientists, or that we've deployed our code into, is in a managed virtual network where we've turned off public access, we need to access it somehow. On my machine, I'm accessing it through a VPN. You can see that down here at the bottom. But you could also access it like here through a bastion, where you walk through a bastion to your jump box, from the jump box through the private endpoint into your machine learning workspace. Once we cover, we continue to cover a bunch more of the networking concerns you have, including things like network segmentation, inbound and outbound rules that you should be implementing or consider implementing for your services. We then hit some of the other WAF principles that we need to be concerned with within this architecture. One of the ones that I want to touch on is redundancy. If you remember, we had an alternate architecture, and this is that alternate architecture where we deployed the machine learning, the prompt flow code to app services. And that's because app services support zonal redundancy. And so if you need zonal redundancy within your environment, then this is an architecture for you. You could also use something like AKS to deploy it. I don't want to walk through too much more of this. I'll leave that as kind of homework. But as you can see, as I'm scrolling down, we're hitting each of these principles and providing you with guidance or things that you should be thinking about when building out an architecture such as this. The last things I really want to touch on here is that this architecture wasn't written by Patterns and Practices. This was written by engineers, customer-facing engineers in the field, including guys like Ritesh, Ryan Faltz, Freddie Ayala, Prabal, Ralph. These are folks that are working with customers, and these are proven architectures that are working out in the wild. The other thing I want to talk about is we're not just giving you the architecture. There were, as I mentioned, 11 billion boxes out there. How are you going to deploy that yourself? Well, we've got a reference implementation with it. And within this reference implementation, we give you the guidance on how you can deploy this yourself. So let's take a quick look at what gets deployed, and then we'll actually see it in action. You can see out here in my resource group, there are the 82, I guess it wasn't 11 billion, 82 resources got deployed. I'm just going to show you a few of the important ones. Here's our search service, and if you see here, these are the search indexes that we've got deployed currently. Here's Azure OpenAI. What's interesting here, if you look under Resource Management, we can see the Networking tab. And under here, you can see that public access is disabled. The only way to communicate with this is through our private endpoints. Here's Azure OpenAI, OpenAI Studio. And you can see down here the deployments. So I've deployed out GPT 3.5 and Ada. You can see here's my machine learning workspace. And if we go down into settings and we take a look at the networking here, you can also see this is disabled. You can't reach it from the public internet. You can only reach it through our private endpoints, if this will catch up with me. There we go. You can see it's disabled. And you can see, again, the private endpoints. Here's another interesting piece. The workspace managed outbound access. You remember when I talked to you about that managed virtual network? This is the configuration setting that gets you that managed virtual network. And if you look down at the bottom here, you can see all of these outbound rules. And because my machine learning workspace needs to talk to things like container registry, needs to talk to Azure Storage, needs to talk to other PaaS services, those private endpoints are created for you and they're managed for you. But if you, like us, need to talk to Azure Search or Azure OpenAI, you can create your own private endpoints or FQDNs. And that's what these guys are.
So Rob, it's not only reliable, performance setting, and all the other architectural concerns it takes care of, but it's also secure by default.
That's right. That's right. Secure by default once you deploy it from our reference implementation. And so let's see this thing in action. So this is our UI that's deployed to app service. We're going to walk through our gateway, through WAF, and talk to this. So we're going to ask a question that everybody should know the answer to. Who won the 2001 World Series. And just like we all know, we're going to find out that it was the Arizona Diamondbacks, led by the great Randy Johnson, that won the World Series. Oh, by the way, I'm from Arizona. So with that, we've kind of taken a grand tour of infrastructure for our POC. We're done, right, Ritesh?
Really, Rob, you think so? We are done?
I do.
I do feel that there is still some issues, and we still need to take care of a few things.
You think we need to do something else? What do we need to do,
Absolutely.
Ritesh?
I think we need to take care of a few things, and let me go through them.
Okay.
So,
Do you want to go to your slides? Okay.
so if you look at it, we have two major components: the orchestrator and the Azure OpenAI endpoint. Now, there's a direct connection between them, which means the orchestrator, the prompt flow, is calling the OpenAI endpoint directly, which itself is troublesome because what happens if you don't get that network? But beyond that, when you call OpenAI endpoint, basically you send a request, which is an HTTP request, and you get a HTTP 200 response back, which is all good till the time it happens. But sooner or later, when you have more users and you have more requests flowing through your orchestrator, at some point of time, your Azure OpenAI endpoint will respond with 429 status code. And what is 429 status code? Basically, it's a way of telling that there are too many requests within the service, and there's a rate throttling that is being applied. So the next request that's coming in primarily is not getting serviced. Instead, you're waiting for that throttling limit to get over. Now, how do you solve them? Basically, this is a problem because then your users are waiting for the request to be over. There are two ways to look at it and solve. One, either we can implement something called a back-off retry mechanism, where from the client, you wait. Whenever you get to 429, you wait for some seconds before raising the new request, and periodically keep on checking whether it's giving you 429 or not. As soon as you don't get 429, you get HTTP 200, for example, you continue working. But that's maybe not the ideal situation to be at, because that's not the best user experience you can give it to your users. What else can you do? One of the other things that you could do is have another OpenAI endpoint, as you can see on the screen. And as soon as you get 429, you make either you have predefined, you have coded already with configuration to make sure that whenever you get 429, you use the other endpoint instead of the original one. Well, it has its own challenges, because how do you move back to the original one? Again, you need to figure it out, because at some point you want to move to the original one because that's a PTU, whereas the second one is just pay as you go. So there are challenges with it, and you need to, at times, bring code and configuration changes on your client application or the orchestrator, which is definitely not something that you would like to do on an operational or production basis. So what do we do? How do we solve this challenge? We solve this challenge by introducing something called a gateway. Now, this gateway is primarily a conduit between your orchestrator and the Azure OpenAI endpoints, which means every request now, instead of going directly to the endpoint, it actually goes to the gateway, and gateway is already configured to reroute the request to the main endpoint, which is your PTU primary endpoint. And now you get, again, the same response as before, which is 200 HTTP OK. But again, at some point of time, you get 429. But this time, the request does not go back to the customer or the orchestrator, but instead, the gateway takes care of it. Whenever the gateway sees there's a 429, it reroutes the request to the other endpoint, because it's already been configured for that. And the response goes back to the orchestrator, but the orchestrator does not even know which endpoint actually serviced it. So the gateway takes care of it completely. There are advantages of this, Rob, in which you can keep on adding more endpoints without disrupting your existing infrastructure and application. You can add more models, plus what you can also do, you can add more clients to it without disrupting your existing clients, which means on a production, if you have deployed such an application, if you want to bring about changes by adding more services, both at the backend or an orchestrator as a client, you could do so with ease without disrupting anything.
So
that's what I would call production ready. What do you think, Rob?
I think you're right. I think we need to implement a gateway, and oddly enough, we have guidance published on Learn about just how to do this. A series of guides that will talk to you about the use cases of gateways, including this scenario. I've got it up here if you want me to just switch over to mine.
Yeah. So let's see how this looks like. So as you can see, this has 3 charts, this report, in which the first one is the number of requests. We did some load testing on this application. And as you can see, we have a steady increase of the number of requests going to the endpoint. The blue line is where the PTU is actually giving you a response of HTTP 200, and the pink one is 429s. At some point, you can see that on the left chart, the pink one starts rising up because we're getting 429s. And at the same time, since we have the gateway in between in the architecture, on the right side, the open AI pay as you go, the number of requests moving to that starts rising. Eventually, whenever the PTU instance the rate throttling is removed, you can see that the number of requests starts falling in OpenAI Pay as you go, which means now the gateway is sending those traffic back to the original endpoint rather than the failover endpoint.
So this is a common pattern that you'll see out in the wild, where you'll have one PTU instance out there deployed, but you don't want to over-provision that. You don't want to overpay for quota that you may not be using. So in order to handle that, you also put out a pay-as-you-go instance and use the gateway. Once you've hit your quota within the PTU, you spill over directly to the pay-as-you-go. So I think we're all done, aren't we, Ritesh? No? We still have to do an application, don't we?
Yeah, I think so.
All right, let's do that. Let's start talking about actually building out a RAG solution. So let me get to the right slide. Oh. Flip through here, sorry. Okay, so what you see here is the same high-level architecture you saw earlier on the top. You see the user is calling into the intelligent app, which is calling into the orchestrator, which is calling down to AI search, which then takes that information, passes it back to the Azure AI service. However, you'll also see at the bottom is a pipeline. And that's a pipeline that you're going to be using in order to take your corpus of data, these documents over here, and moving those, chunking them, enriching them, and embedding them, persisting them, so that they can exist in your Azure AI search so that they're available. And while this might look simple, the devil's in the details. With every step you see here, there are going to be questions that are going to come about. What test queries should I use? What test documents should I use? How many is enough? What chunking strategy should I use? What are the chunking strategies? And how does the structure of my documents influence the strategies that I'm going to be using to chunk when I'm enriching? How should I clean my chunks? What should I clean? What should I add to my chunks? How should I enrich them? What are the options? What are general guidance that people do that? What embedding model should I use? Why do you care? What's the difference between embedding models? And what's the guidance on which embedding model I should be using? When I go to persist, how should I build my index? And then what kind of search should I do? Should I just do a vector search? Should I do multiple searches? Should I do full text? Should I do manual multiple? And should I, as Ritesh said earlier, some of these questions are going to be so complex, you can't answer it with just one set of data. So do I need to break my question down into a bunch of questions? And how do I do that? And then lastly, how do I test my system from end to end? All of these are very difficult questions that my friend here
I thought this would be easy.
is prepared to show us after I show you some of the published guidance that we have. So once again, we put together a guide which just released this week on designing and developing a RAG solution. So if you look at this guide here, you'll note that little set of questions that we have came directly from this guide. And if you look on the left-hand side, the table of contents, you'll see that there are a bunch of articles as part of this guide. And they generally follow those sets of questions that you want to ask. So for instance, in the preparation phase, this tells you where to gather your guidance on gathering the right test documents and gathering the test queries. And the chunking guide, we talk about the chunking approaches from sentence-based to fixed size. all of the different chunking strategies that are out there. We tell you the tools, we tell you the engineering effort, the processing cost, use cases, and specific examples. And then we get into how the document structure should help influence your choice on what chunking strategy you should be using. The chunk enrichment phase. We talk about here about first cleaning, what you should clean and why, or what you should test cleaning and why, right? Everything's testing. And then about augmentation. What fields should you add in or should you consider adding in and why? When we get to the embedding phase, generating embeddings. What's the importance of the embedding model? Why do you care? And then how do you choose an embedding model? The information retrieval phase. We talk about guidance on generating your search index, and then the different search types. A vector search, here's some guidance on how to do it. Full text search, hybrid search, manual multiple. And then we get into the guidance, and you can see here, if you wanted to break your query down into multiple subqueries, here's some guidance on how you can actually do that with a large language model. All of this and more, Ritesh. Am I right?
Absolutely.
All right.
So
the very last thing is we have a guidance that will take you so that you don't have to figure out how to implement all this yourself, don't we?
absolutely. So I think we are just in luck. If we have to answer these questions ourselves, it is extremely complex job to do it. But incidentally, we have the RAG Experiment Accelerator. So as the name says, it's an experimentation-based tool through which we can answer all the queries Rob was just talking about using this tool. It's, as I said, this is a configuration-based tool, and it can be configured to extract insights out of documents. So you bring your documents into RAG Experiment Accelerator, you configure it, you run a series of steps, and you would be able to extract answers to the queries that you just raised about. You can, and this is the repo that I'm talking about. It's an open source. You can access this directly. And I'm going to show now how do we use this tool to actually get answers to something like how should we chunk it, how should we embed it, what should we use for embedding, and things like that. So the main configuration, there's a config file, config.json, within this repo. And it has a series of configuration items. Now, to make it easier to understand what this config looked like, you can see that we have categorized them into index, query, evaluation, and general. So once you bring your data, we have predefined steps that you should be executing, like indexing, the 0, 1 index, which is a step where you primarily decide how you want to index your documents. So let's assume that this document that we're talking about, Dora, you get that document. That document is stored within the docs data folder, and this repo, actually this solution that supports docx, HTML, JSON, Markdown, PDFs, text, and you can add more if you have some other formats as well. So we have the documents over here within the PDF folder. Second, when we index, we need to decide how do you want to index. Before that, we need to think about whether you want to pre-process the document or not, because the document might have content like Unicode characters. You might want to remove them. You might want to convert the text into lowercase, the uniform case, and things like that. Other thing that you might want to also think about, whether you want to generate additional metadata for the chunk or not. If you want to generate metadata like title, summary, which might help you aid in a better results when you're actually indexing your documents. The third, how do you want to chunk your document? Whether you want to use sentence-based, boundary-based chunking, or whether you want to do semantic chunking, and what should be the size of the boundary-based chunking, you can all determine during the indexing phase. When you come to the QA generation, because you would like to experiment, this is an experimentation tool and you want to experiment, you would like to have some questions and answers so that you can use them to test your solution. Either you bring it on your own, and this is an optional step, or you generate them using this particular step. The third one is the querying bit, where you actually take those queries generated as part of step 2 and then send them to the index. Extract the output from there, which is the information retrieval, evaluate them, and then send it to the OpenAI with the context and extract response from it, which is your final response. And you would like to evaluate even the last response that you get from OpenAI. Now, while you do that, the querying can be extremely complex because you might, if it's a complex query, then you would like to break it down into subqueries and use each of the subqueries against the search index and then go to the same process I just mentioned. It could be that you want to augment the query itself with additional data to make it more conversant with your index. So there are multiple things that you can do with your query, and some of these configuration items that you see here are related to that. So whether you want to do pre-processing, whether you want to do chunking, how you want to do chunking, what should be the size, whether you want to generate metadata, what kind of embedding model you want to use, you can choose that, what should be the size of it, and some of the other things that impacts your index. Similarly for the query, which kind of a query you want to use, whether you want to use text-based query, vector-based query, a hybrid approach, or a semantic approach, you can determine from here. Whether you want to expand your query using the additional data that I was just talking about, you could do so. Same for the multiple questions. You could also do re-ranking, because once you get the response, you would like to see what chunks are more applicable or relevant to your query, and then use only them. So you can say, I want to do re-ranking using large language model or a cross encoder, and then take the top 3 or top 4 over here in this case, and then use it. What kind of matrix you want to use? How do you want to evaluate? It's very important because you need to determine this. Because every use case has a different way of evaluating. If you're doing summarization, a Rausch matrix might be more applicable. But if you're using something like trying to compare, you're trying to get an answer and see whether it matches to the query that you're doing, like a semantic comparisons, then cosine is one of the ways to do that, but there are others as well, like we are using BERT-based model, and the other ones like relevance and precision are related to information retrieval. There are some more other ones, but they also impact how you want to configure it. But just by configuring the first time, you can, this tool is actually is integrated with Azure Machine Learning Workspace. So whenever you run an experiment, all the steps that I just mentioned about, you are basically running a job within Azure Machine Learning Workspace, and it's connected through MLflow. So those jobs actually look like this.
So while you're bringing that up, it sounds like all of the guidance that we showed you, you're able to configure into this tool. You look through that guidance, you make your determination on what you want to do, what your chunking strategy is, whether you want to re-rank, et cetera, and you're able to test it within this tool. Is that right?
Absolutely. So you should start with, when you start with this, you will start with some basic configuration as you're seeing here. Then incrementally change them, keep running these steps again and again, and these all are getting logged, so you can eventually compare them. As a matter of fact, what I did, I have created 5 different experiments over here. Let me show you what those experiments look like. So these experiments basically differ in some configuration value over here that you see. For example, the chunk size for experiment 1 is 1500, whereas it's 2000 for experiment 4. Similarly, I have used different embedding models, I have used different dimensions, different chunking strategies in some of the experiments, and I have trying to find out which configuration will work best for my documents, because every document is unique. We need to experiment and find these hyperparameters, which is what we want to take it to the production. And how does it look like? Let me show you that. So when you actually come to any of the jobs that you see here, when we run this job, we make sure all the metrics that we have configured for are logged. Every hyperparameter is also tagged, and as a parameter is been mentioned over here, so that we can easily compare. So when since we have 5 experiments, we can compare them. We can assign the first experiment, for example, if you don't have any predetermined data before, you can compare them, assign one of them as your baseline, and then see which one is working better for you. So the first one is my baseline over here, as you can see, the first experiment that I did. And as I did my second experiment, the performance dropped drastically. As you can see the difference between them. The third one was much better, and the fourth one actually performed the best. I can determine my threshold, that this is the threshold for my matrix that I'm looking for. As soon as it crosses, I'm good with the performance of my application. I can go to the production. So this one gives me the name, which says I have been using metadata. I have been using embedding model, and I was doing some pre-processing as well. I can always look at this job. I can always look at this job that ran in Azure Machine Learning Workspace, figure out the hyperparameters, come back here, and push that index back to my production. And that is one of the ways you define a systematic scientific approach and methodology to determine what would work on your production. So we saw the infrastructure, we're now looking at the application, and without experimentation, it is extremely challenging to figure out how your RAG application is going to behave on production. So that's how, Rob, we think we should be thinking about applications and try to answer all the queries that you raised about using RAG Experiment Accelerator.
Yeah, just to kind of bring that home again, all of the questions, all of the guidance that we saw walking through those documents, it is highly complex, and there are no right and there are no wrong answers there. You have to experiment with it. You have to test it out. You have to be able to look at it historically. You also need to make sure you're not regressing over time, because things change. You're going to get more documents in your corpus. This isn't a one-time, once-and-done type of operation. So this is an experimentation framework that's going to allow you to evaluate over time. Now, I've got a surprise for you, Ritesh. While you were busy talking about the Experiment Accelerator, I took our baseline and I pointed it at the index, your good index that you created. And so now we've got a question that we can ask of the DORA document.
I can't wait for it.
So we're going to ask, what measures should be taken by competent authorities in the case of criminal investigations or proceedings for breaches of the DORA regulation? Now, this is going out to Azure AI Search through all of our private endpoints eventually, and we're going to get back this giant set of guidance. Voila. And with that, we've kind of walked you through all of the steps. And I know this was fast, and we went through it quickly. And we didn't mean, our goal was not to walk you through exactly how to do everything. The goal was to show you the guidance that's available to you on Learn and through the RAG Experiment Accelerator that you can use when you're at home. So just to kind of recap what we did, we started with the POC running inside of Azure Machine Learning. We were using PromptFlow. We then used the baseline architecture that's available on Learn. We read through to understand what are the design considerations we need to understand when building out such an architecture, and we used the baseline implementation available on Azure Samples linked from the architecture to deploy it. We then implemented a gateway, following the guidance that we have in Learn on implementing a gateway for OpenAI. And we did that so we can handle things like throttling and implement that pattern that we talked about, where you have a pay-as-you-go sitting behind your PTU instance so you can handle spillovers. Lastly, we talked about actually building our application, building our RAG solution. We read all of the guidance from the beginning to end, tail to end, on gathering the right questions, gathering the right test data. How do I chunk? What are my chunking strategies? Why do I chunk? Walking through enriching those chunks, cleaning our data. Then walking through creating our embeddings all the way through our searches. And then how do we automate all of that so we can do it in a scientific manner, evaluating it.
This was fantastic. However, I just wanted to cover one more piece to it, is that you have a set of queries. Now, how do you determine what you should be doing to move forward? So for example, if you got the recall as 70%, how do you make sense out of it? You got precision as 60%, how do you make sense out of it? How do you know what is the causal inference? What should I do back, again change, to make it better, right? This is all there in the guidance that we have for the RAG end-to-end solution. You can always read that, but in general, for example, if you see the precision is low, what does that mean that the precision is low? Is that you got 10 chunks, out of those 10 chunks, you have chunks which are not relevant. How do you make sure that all the chunks are relevant? Either look at your embedding model, check whether the search type you have used is right or not, and things like that. Those will help you determine whether you're in the right direction or not. And once you come to this place and compare them, you will figure it out that whether it's working for you or not, and then you take a decision how do you want to move forward. That's just what I wanted to cover.
Good. Well, that's it. We've got some folks that have been managing some of the questions that have been coming in online. Are there any good questions that you guys want to post up here, or? While he's looking for those, are there any questions out here? Anybody got one here?
Is there something about grounding also in this particular case? That how do you ground? Because I don't know if Dora chat should be answering who won Arizona or who won the World Series or not. So Is there something about in the guide?
So you're talking about how do I route to make sure I'm going to the right back-end system in order to gather that data? We don't have any guidance in here right now.
But I can answer that too.
Yeah.
So basically, what you do, there are multiple ways to look at it. One is routing of your request. So when you get a request, you try to find the intent of the query itself, and based on the intent, you try to find which route it should go to, whether it should go to DORA or it should go to somewhere else. But if you're creating a chatbot, you should not be answering for a football compared to DORA, right? So it's a very general, it's either a general purpose bot or a DORA bot, for example, right? So first stage is that. Second, you can put some routers, as I just mentioned, to make sure that it happens, that you route to the, if in case you have multiple use cases within the same chatbot, you could do so. Third is look at your prompting. That prompt engineering is quite important. You have to make sure that your prompts actually help you redirect the request back to the right router to make that happen. So I think if you bring these things together, it should be able to work for you.
Yeah, so that can be actually part of your prompt, part of your flow where you categorize the question or the intent of the question coming in and then route it to the right back end. So hopefully that helps. And he meant to say baseball when he was talking about not football.
We have two good questions online here that we could address here. The first one is there guidance on how to approach building indexes from an ops standpoint?
So I think that's getting into kind of the LLM ops and ML ops, and we do have some guidance out there. In fact, you've got a nice.
So if I understand the query properly, it says how do we do operations on the index?
How do we approach building indexes?
Okay, so there are two different. I think there are multiple vector databases in the market. If you're looking at Search AI, for example, there are two ways to look at it: push and pull. So either you can push your data to the index, and then you need to somehow manage if you want to have increment data coming in, how do you want to push them further? The other way is to pull information, which means the search index has something called an indexer. It can go out to the various different data sources and read those data and index them and get it back into your index. So when you use the pull based, it will automatically find what's incremental, what to override, what to delete, and it will keep doing it in the background. So you will have much more control when you do pull based search indexes. So that's how you should be thinking about it from an operations perspective.
Okay. I have two new questions in the one that I was just mentioning. So the next question is, as a data scientist, what tools would you recommend that I specialize in?
Okay, so that's a very general purpose question. Actually, there are quite a lot, and it's very difficult to answer that. But if you think about it, when you're thinking about a chatbot like this built based on Gen AI, there are quite a few tools. You need to think about large language models, how to use large language models, how do you fine-tune large language models. Think about LLM ops, think about RAG, and how do you bring them together. So these are the main different areas that you need to look at, and for each of them, there are multiple tools. You want to use Search AI for your indexing. You might want to use some other tools. Also, vector database is also available. If you're thinking about orchestration tools, you have tools like PromptFlow. You have semantic kernel, LangChain. You can use any one of them. So you should be knowing about them. And how do you bring them together is also quite important. So I think some of the tools I just mentioned, but this is a very general purpose, and we can talk about it later offline as well.
I think also it's kind of more important to understand the theory behind it, which is why that chunking guidance is probably where I would start. Using a different tool, using one tool versus another is easy to pick up once you understand the hows and the whys and the right questions to ask.
So one of the follow-on questions was a clarification to the ops question, the indexing question. So it is related to ops standpoint. So if you were to approach building indexes, it seems like this is both a data engineering and an AI/ML process, which is effectively a shared responsibility. So how would you approach that sort of shared responsibility?
Okay, so if I understand your question correctly, the question is the indexing process is both data engineering as well as part AI/ML as well, right? So how do you approach that? Okay, so data indexing Absolutely. It is a large portion of it is data, because when you get data, you need to think about how do you want to pre-process that data. What kind of a exploratory data analysis you want to do on that, and then how do you want to chunk that data? How do you want to make sure what kind of additional metadata you want to generate and things like that? Those generally becomes part of data, but at the same time, when you look at embeddings, what kind of a domain embedding you want to use, whether you want to use a general purpose embedding, what should be the size of that embedding, the dimensions for the embedding, whether you want to reduce the dimensions and want to evaluate when your query comes, whether it's matching to the content, how far the distance is between the query and the actual content. All of these things falls within the realm of the data scientist. So, as I said, this is all part of experimentation. So I think when they both need to come together actually as part of the process and look into it. So once the data comes in, how do you want to generate embeddings? So you need to do experimentation with embeddings and then accordingly decide how best to actually bring them together. And this experimentation tool will actually help you do that, because you just need to configure this as well and run it to get the initial insights, and then eventually get it validated by both the data engineers as well as from the data scientist.
So if we have time for one last question.
Sure.
Okay, it is the meeting, right? What do you recommend specifically using in Azure as the gateway to LLMs? Something like LLM, light LLM proxy, or something Azure specific?
When you're talking about the gateway, APIM is what we see most of our customers using, Azure API Management. And you'll find that if you look in the gateway guides that we have, you'll find some references to that, as well as I think we've got some architectural diagrams in there as well. Okay. Well, thank you all very much. Appreciate it.
Thank you.